So the earliest very nice observations were done by a Danish businessman and a German mathematician. So Kepler was a German mathematician and he was employed by Tycho Brahe, and they recorded the data of the sky for 40 years. Okay, so this was their hobby. So they were looking at the sky, how do the stars and the planets move. Okay, Kepler gave three laws. First law is the law of orbits. So according to the law of orbits, all the planets or celestial bodies, if they are revolving around each other, then they have an elliptical orbit. Suppose S is the star, then the star is at one of the foci. There are two foci, F1 and F2. Okay, then the planet will move in elliptical orbit. The orbits can be elliptical and circular both. Now, the problem is in nature, there can be a small amount of, dissimilarity, or it's not perfect. Usually, elliptical orbits are observed, but it is equally likely that circular orbits can be there. So you can see circle is a spatial ellipse which has both major and minor axis same. Okay, so you can look at ellipse has this as a minor axis. इलिप्स जो है अंडे टाइप का शेप का होता है। एक ये एक्सिस ये कहलाती है मेजर, ये वाली एक्सिस कहलाती है माइनर। Okay, and in circle they are the same. So his first law was planets follow elliptical orbits. Okay, he did it. His observation is later proven mathematically. Okay, so first things are just human ideas. There is no logical setting why Kepler thought it was elliptical. It was his guess. Maybe he liked this is the simplest curve he could fit on the data. Now, in those days, there were no satellites. You just go to the roof and you observe a thing and you locate it, and then by mapping the angular displacements, they came up with this hypothesis. Now, the second is the law of aerial velocity. First is law of orbits, then the law of aerial velocity. In this second law, what Kepler said was if something is under an orbital motion, for example, a planet P, then per unit time, the area that it sweeps is always constant. So you see, if it goes from P to Q and R to M, then the area swept are equal. So aerial velocity is constant. And we will prove it to be its angular momentum by 2m. If something is in elliptical orbit or any circular orbit, there is no external force, then the angular momentum should be conserved. This is the only thing we will use from rotational mechanics. Since angular momentum is conserved, the area swept per unit time is fixed. The third law is law of periods. Okay, what does the law of periods say? So according to law of periods, if something is doing an orbit about a planet or a star, then the time period of that planet is proportional to its distance from the body around which it is doing the orbital motion. Is radius t square is r cube. Okay, so this is the law of periods. This law of periods That was known to Newton. Okay, so Newton came maybe 100, 200 years later after Kepler, and he found this T square is R cube law. And this gave him the hint to define the universal law of gravitation. So, universal law of gravitation is derived from the law of periods. तो इसमें किसी का कोई डाउट, कोई क्वेश्चन? Be strong.